Hello, good morning, afternoon, here from Nataf, a small village in Israel. It's a pleasure to be here, and I certainly hope to be in 2 years' time in Venice, as was planned this year and was not possible. I'm going to talk about research that is going on at the Weizmann Institute of Science in collaboration with other scientists, notably Luca Cardelli from Oxford, Ehud from WZB in Germany, in Berlin, EUI in Italy, and IDC in Israel, Shahaf from Weizmann, and Nimrod Talmon from Ben-Gurion University. And our goal is indeed to provide a computational foundation for digital democracy, and more specifically for establishing an egalitarian and just digital society. And the reason we embarked on this is a realization that our current digital society is really very far from being egalitarian and just. In fact, we believe, and the first time I said it was actually in a conference in Davos about 4 years ago, and since then I think it became a household kind of belief that today our digital society is controlled by feudal lords, and we want to change that. And furthermore, we believe that the fact that our digital society, which is so dominant in our life, is feudal, is actually hampering our earthly democracy. So really a precondition to fixing our earthly democracy is first to fix our digital society, and hopefully this will radiate and also improve our earthly democracies. And why do we claim that the current digital society is feudal? If you look at how our digital platforms operate, they operate exactly like feudal lords of yore have operated. They set the platform's rule of conduct. They are the legislative arm of the platform. They interpret them. They're the judicial arm of this platform. They set they decide on the punishments, and they implement their decisions, so they're the executive, and along the way, they also violate the dictum, no taxation without representation. This is a kind of indirect or reverse taxation, in the sense that they don't give any share of the income to the citizens who produce the value in these platforms, but rather keep it all to themselves, and at the same time, or keep almost all of it to themselves, depending on the platform, and at the same time don't give any representation to the participants in these platforms. So what we believe, is that our digital society should progress from the Middle Ages, at least a small step, to the age of enlightenment. And we take ideas from the age of enlightenment, specifically the idea of the social contract, not in the sense of Rousseau, which says that part of the social contract is that people give away their power to the state in return for protection or in other rights, but rather in the sense of the founder of anarchism, of Proudhon, who said that a digital social contract is a voluntary agreement among free people. And we take this approach seriously and literally into the digital realm, and have, as a result of several years of work in this area, have come up with this concept of digital social contract. And this is it's a novel concept, and it's a bit difficult to explain. So this slide is really very dense. And I should say that it's backed by several research papers of our group. They're all available on the Archive repository, ARXIV. And if you want to dig deeper into the mathematical aspects, because our work is almost exclusively mathematical. Here I present it more conceptually and informally, but the gist of our work and the foundation of our work is all mathematical. So if you want to see the mathematical foundation of our work, you can go to our papers. Here I'll leave it at a high level kind of explanation. Still, I'll try to explain what is a digital social contract, First, conceptually, it's very much like Proudhon's concept. It's a voluntary agreement among individuals, except that it's digital in the sense that it's specified, undertaken, and fulfilled in the digital realm. So there is nothing in it, nothing physical in the digital social contract. Everything in a social contract happens digitally. From a mathematical point of view, for those who are familiar with the foundations of computer science, then there are many, many abstract models of computation. There is a zoo of mathematical models of computation in computer science. So in some sense, digital social contracts are yet another mathematical model of computation, an abstract model of computation. More specifically, it's a so-called transition system, specifying concurrent, non-deterministic, asynchronous. So these are all computer science keywords. I will not have time to explain them, but each of them stands for a bunch of mathematics that defines what they are. So it's a transition system specifying concurrent, non-deterministic, asynchronous, agents engaged in crypto speech acts. So what do I mean by crypto speech acts? Those who are familiar with linguistics or theory, there is a notion of a speech act, which is the ability to execute an act by talking, such as crowning someone. You know, I crown you to be a king, or I, unfortunately, divorce you, or I marry you. You know, these are all speech acts. So all these acts are carried by performing a speech act, and we have the digital counterpart of a speech act we call crypto speech act or a digital speech act, which is signing with a digital signature a statement and then presenting it to everyone. And the essence of a speech act is it's non-repudiable. Once you've executed, everyone can see it, and you cannot deny that you've done it because you have signed it. So that's the mathematical foundation of digital social contracts, people saying to each other speech acts in a non-repudiable way. Computationally, you can view digital social contracts as just a bunch of software running on a distributed system. And to execute it precisely, we need a programming language. To specify it precisely, we need a programming language. So we have actually defined a social contracts programming language and are working on its implementation, where you can specify digital social contracts. So the idea is that same way that a lawyer specifies a contract in English or Italian or Hebrew, then digital social contracts will be specified in a digital social contracts programming language, which we are working upon. And those who are familiar with smart contracts and their programming languages, then this is not the same, but it's analogous. Technologically, once we have all this working, you will not see all these things. It will be a digital system operating, and the best way to describe it is as a programmable, distributed, locally replicated, asynchronous blockchain architecture. So here we come to the actual technology that we anticipate digital speech acts to run on. So it's a distributed ledger blockchain architecture, which we hope will operate on mobile phones and tagged by genuine identifiers of their owners. So I know this is a dense slide, and I will try to give some examples that hopefully will make this more understandable. Maybe if we can talk about concrete applications, you will see the difference between digital social contracts and the current digital realm. So the first application, which we envision, or one application we envisioned, is self-governed democratic social networks. So as opposed to Facebook, which is a feudal social network, we anticipate self-owned and self-governed digital social networks, for example, an alternative to Facebook. And if you try to think about it, the challenges of doing this today with existing technology are, I would say, insurmountable. Because there is no technology today that allow people to self-own and self-govern a digital system. The closest technology we have today for this is blockchain, where you have people share a digital currency and operate it concurrently based on agreed upon rules. That's the blockchain protocol. But digital currencies today, cryptocurrencies today, are not democratic. They may be owned jointly by the community that operate them in some broad sense of the word, but they are very far from being democratic. They're not egalitarian, they're plutocratic. There's no democratic decision-making. And there's no equality among those who operate it, and so forth. So if you wish to think of an analogy to what we do, then blockchains are an excellent analogy, but they are very far from the ideal that we envision. Another application that you could envision to be an application of digital social contracts is self-governed digital political communities, and specifically the topic of this session, digital parties. How can such parties form and operate? They need lots of components. For example, shared digital assets, democratic decision-making, and so forth. And we envision all these to be specified and operated by digital social contracts. We're also working, and we actually have publications on this, as I mentioned, on the archive and in other venues, of cryptocurrencies which are different from today's cryptocurrencies. They're different in the sense that they're egalitarian and just. Egalitarian in the sense that they are controlled equally by the people, not in a plutocratic sense that the more money you have, the more control you have, but the control is shared equally among all the people. And just in the sense that they implement distributive justice, that money is minted not by winners of lotteries, that the more money they have, the higher the chance that they can win, but they minted equally and could be a foundation for universal basic income in the digital realm. And finally, another example application is sharing economy applications like digital cooperatives. And we hope and plan and anticipate that in due course, when this approach or competing similar approaches will be successful, then the current authoritarian and feudal so-called sharing economy applications such as Airbnb and Uber will be replaced by truly sharing economy applications which are self-owned and self-governed. And again, we envision this as an application of digital social contracts. So I will not spend time on actually going through the details. I'll just give you a sense of how this looks. So here's just an example, a very a simple-minded example of how a digital social contract for Airbnb will look like. So this is the rules of behavior of a tourist. Again, just so you have a feel, I will not go through the details, but that this is a digital social contract for the tourist, and this is a digital social contract for the host. And when they execute it together, they behave according to their joint digital social contract. And another example is an egalitarian currency. And it's egalitarian in the sense, as shown here, that upon every clock tick, the balance of every participant increases by 1 coin. So this is not like Bitcoin or other currencies where winner takes all, but here new wealth is distributed equally among all participants. And for those familiar with the current blockchain architectures, I'll just try to give a feel for how digital social contracts are different from standard existing blockchain architectures. And this is rather technical, but I will just say that we're in the same realm, technological realm as blockchain architectures, but we offer a different approach that may solve at the technology level some of the main challenges of existing blockchain architectures, notably the lack of scalability resulting from complete synchronization and a single shared ledger. In our case, it's a distributed ledger, it's asynchronous, and therefore could scale to applications which are similar to in scale to those needed by Facebook or Airbnb, etc. So in closing, I will just say that this is we are part of a very long-term project. Hopefully not too long-term, but it is a long-term basic research project. We're still working on mathematical foundations of digital social contracts, and as I said, you can see our mathematical papers in the archive website, and we work in many different directions. For example, addressing the principal agent problem, and distributed ledger implementation, and designing and developing the programming language, and hopefully then address the many applications that are possible. So I think this is a good time to stop and take any questions if there are. So let me spend a few more minutes on this very dense slide to try and give you a feel for what digital social contracts are at all these levels. Let me start from the conceptual level. It's hard to understand what is the value of an agreement which is voluntary and is done purely in the digital realm. What value can we take out of an agreement that's carried out purely in the digital realm? It seems like almost pointless, but there are so many assets today that exist purely and entirely in the digital realm that once you try to envision them as part of a digital social contract, then you can see that they could be highly valuable. For example, the entire value of Facebook or Instagram or WhatsApp is in the digital realm. They have no physical assets, they have no physical presence. Everything there happens in the digital realm. So if you could substitute these feudal systems with democratic, self-owned, self-governed systems, they would still have the same value. You know, they will still have the same value to their participants. Perhaps they'll have more value because their control, their management will be democratic. People will feel participation in it. They'll feel they're a part of it. So they may be even more valuable to their participants than the present systems. Still, they exist purely in the digital realm. Another example is cryptocurrencies. Bitcoin, Ethereum, etc. They exist purely in the digital realm. They're just an agreement among people. It's not a digital social contract because there's no contract. It's a piece of code that everybody agrees to run, and there is no underlying foundation similar to digital social contracts, but it's quite close in the sense that only if everybody obeys the same rules of operation, then this entity, Bitcoin or Ethereum or any other cryptocurrency exists. So saying that we have something that exists purely in the digital realm doesn't undermine its value. On the contrary, we can see that many things that are of extremely high value in today's society exist purely in the digital realm. So that's regarding the first point. The second point, and please stop me if the session ends, I'll join the main session, but until then I'll try to share my thoughts. The second point on the mathematical model of computation, this goes to the core of what we're doing, because what we're trying to do is develop a very foundational notion that rests directly on the underpinnings of computer science, like other basic formal models of computation, so that we'll have a solid mathematical foundation to build upon. And the reason is that if you have a solid mathematical foundation, you can much more confidence that what you're doing is not ad hoc, is not